on looking at our chemistry today. We'll do bite blocks afterwards. So the last couple of days we've been looking at masses of atoms and the different types of masses. There was relative atomic mass and relative formula mass. And today we're going to learn how the formula mass means we can actually calculate percentages of the elements that are in the compounds. Okay, so today we're going to use the formula mass so we can make, so we can work out the P, E, R, C, E, N, T, A, G, E, S. Yeah, the percentages of the compounds, that's correct. Okay. Now this is quite maths based, so I know you're fantastic at maths, but you know I'm going to need your help and patience today to make sure I get it right for you. So we're going to work together properly today because you're going to help me explain this. Okay. So first of all, why is a formula mass, a relative formula mass, why is it relevant and why is it useful? Well, first of all, it's about, as I've already explained, it's important because we can calculate the percentage of a mass of each element inside a compound. Now this is useful because it's used in different laboratories around the world. It's used in geology, it's used in mining, and they work out whether a mineral is worth exploiting or not by using the relative formula mass. So one of the areas of the world that it's useful in is G, that's right, yeah, mining. And they use it in mining to work out whether they should bother exploiting different types of M, I, N, E, R, I'll go back to your A, L, S. Okay. Now, so the minerals. So yeah, they use it in those areas. So how do we actually work out the amount of an element in a compound? How do we do it? Well, first of all, we use the relative atomic mass, and the symbol that we use for relative atomic mass from this, can you remember from this week? No, you can, is capital A and a little r. And we also use the relative formula mass, and that symbol is capital M and little r. Okay, so they are the abbreviations you can use today as well. So the first example we're going to do. So what percentage of mass of white magnesium oxide is actually magnesium and how much is oxygen? So we're going to try and work out what the difference is. Now first of all we need the formula of magnesium oxide, and that is Mg for magnesium and O. So there's no numbers in that, so it means it's just one of each. The second, we then need to know the atomic value, the values of the atomic mass, the AR values. Magnesium is 24 and oxygen is 16. To work out the total mass, we'd obviously add both of those together. So 26 add 16 would be 40. Fab. So we have 40 grams in total. So therefore we know now that 24 grams of 40 grams is magnesium, but we don't know the percentage. To work that out, we would divide the mass of the element we're interested in divided by the total mass of the compound. So in this example, the magnesium, the total grams of magnesium was 24, and we would divide by the total mass, which is 40. Fab. And so 24 divided by 40 which will give us 0.6. Great. Now to change that into percentage, we obviously need to, what action do we need to take first? We need to multiply by 1, 0, go back again, back to 0. I know you know the answer. It's practice for us both and helping me learn. 100, great, so 0.6 times 100 will make it the percent of 60%. So we now know that 60% in magnesium oxide is actually the compound, or the element, sorry, Magnesium. Fabulous, magnesium. Okay. Right, so we'll do another example, this one. So now we're going to look for what is the percentage mass of hydrogen in methane. So we're looking at the percentage mass of hydrogen in Fab, in methane. Just out of interest, the first thing we obviously need to do, well actually I'll do this first, the first thing we need to look for, the information we need, is the actual yeah, you're right, start with F, O, R, M, U, L, A. Yeah, the formula, otherwise we can't go anywhere. So just out of interest is what I was going to ask first. Do you know the formula for hydrogen and for methane? Do you know it, yes or no? Yes, what? So the formula for methane is C. Fabulous, it is, it's C followed by, let me to get it for you. C H. Yeah, we do. Yeah, I'm filming because it's going to be useful for your mum to help me with this as well. C H. Fabulous, Christopher. You really are really good. Okay, so the formula is CH4, and we now need to know what values. What values are we looking for now? And you can use the abbreviation rather than doing it. The A, yeah, the AR values, the relative atomic mass. Okay, I'm sure you might know this as well. The AR value of carbon, the atomic mass of carbon. 112, fab, and of hydrogen. 1, brilliant. Okay, so the next thing we're doing is working out the total mass of CH4, which will be 1. Yeah, we're working 5 at a time. Do you want me to put that on? There you go. 1. 16, great. So the next thing we need to do is a division. We need to divide the element mass by the T O T, brilliant. T O T A L total M A S. That's right, and then turn it into a P E R C. Brilliant. Keep the E. Great. N T A G E. Fabulous. And then percentage. So for this one, it would be 12 divided by 16, and the percentage would be, percentage of hydrogen in methane would be 75%. Brilliant. Okay, remember these. Okay, example number 3. We're looking at ammonium nitrate. That is a fertiliser that we use to grow vegetables, and what we want to know is how much of the percentage of ammonium nitrate is hydrogen. Now the formula for this is NH4NO3. So as you told me last time, we're now looking for the AR values. So you've already told me hydrogen is 1. Just out of interest, do you know the AR value for nitrogen? Yes or no? No, it's 4. Thanks for telling me. It's 14. And oxygen is, remember oxygen from the other day? You probably do. 1, 6. Fabulous, yeah. Okay, so hydrogen is 1, nitrogen is 14, and oxygen is 16. So if we go back to that formula, NH4NO3. Can you add up the total mass? Can you do that in your head, or do you want me to do the sum? Would you like to do it in your head, or do you want to do the sum? The sum, okay, lovely. So N is 14, add 1 times 4 of hydrogen, add another 14 for nitrogen, and then 3 times 16 for oxygen. So obviously 1 times 4 is 4, 3 times 16 will be 48, fab. So the total mass is 48, add 14, add 4, add 14, which will equal 8, 0. Brilliant. Okay, so now we're going to do our division again. So we're going to divide the total, the element mass, of which we're looking for nitrogen, and we're going to divide that by the total mass. So the total mass is 80, and the total hydrogen mass will be 28. Okay. So can you do 28 divided by 80 in your head, or do you want me to, in your head, great. So 28 divided by 80, then turn that into percentage, will make 'So the percentage of nitrogen in ammonium nitrate is 35%. You're amazing. So let's see, but we can carry on here. We're doing really good. Hey, we're going to carry on here because the next one is about a crime scene. Hang on, we're going to sit here. We're crime. Yeah, 5 more minutes. Hey, Chris, come and sit back down. That's right. Oh, have a wee, that's a good idea. Yeah, we're doing 5 at a time, that's right. No, yeah. Come to the table, great job. Okay, so the next thing we're looking at is a crime scene. the police have turned up. It's a murder scene, and they've turned up and they've found a white powder in there, and they're not sure whether it's something called strychnine, which is strychnine. So the next one we're at is a CRIM, and we'll be going on thereafter. E. Crime. SCENE. Fabulous, a crime scene. And we're looking to see if there's a poison. Now, if it is strychnine, then there will be 83% carbon in the white powder. Now, the formula we have for this is C2H22, N2 and O2. Right, so we now know all the AR values for those. So we know that carbon is 12, we know that hydrogen is 1, we know that oxygen is 16, and we now know that hydrogen has an atomic value of 114. Fab. Okay, so let's create that sum. So we have 2 times 12, add 1 times 22, plus 2 times 14, plus 2 times 16. So we're going to make that 2 times 12, 24, add 1 times 22, 22, 2 times 14, 28, and 2 times 16. Sorry, darling, I wasn't watching. 32, yeah. Sorry, just thinking. So 24. Oh, I've written that down wrong. I thought I had. Sorry, honey. It's C12. So that means it's 12 times 12. Sorry, 12 times 12. That would have made the whole thing wrong. 12 times 12 will give you 252. Fabulous, thank you. Sorry about that.
Well, I know.
Yeah, I'm watching that. We're going to work through this. We're doing really good. So it's 252, add 22, add 28, add 32, which gives us a total mass of 334. Brilliant. Okay, so to work out the mass, the percentage of carbon within that formula, the total mass, as you've just told me, is 334. We need to divide the total mass of carbon into that, and the total mass of carbon was 252. 252 times 100 will give us the percentage. Okay, do you want to do that in your head, or do you want me to get in your head? Lovely. So 252, we can go to one decimal place. 252 divided by 334 times by 100 will make that 70 by 0.4%. Great. That's the original instruction at the crime scene, and the strychnine was meant to have 83% carbon. We've found 75.4% carbon, so the conclusion they would draw is that or where do you want to go? S is N O T. It is not S. Tricky spelling, isn't it? S T R Y. Very good. Keep going. Go for your C. That was beautiful. Go for your C. I think it's a C. Yeah. Well done. Keep going. So it is not S T R Y. C-H-N-I-N-E. Yeah, fabulous. It's not strychnine, or however you say that. Okay, brilliant. That's quite an interesting job, I think, working in forensics. Now, an interesting thing is that we can actually also do this backwards, okay? Now, this is something we can do, and we can create an empirical formula. And how do we do this? Well, we're just given the percentage composition of a compound, and then we can work out the ratio of the number of atoms in the compound. So to do it backwards, we will create a formula which would be called the I'm really proud of you, doing really fabulous. P-I-R-I-C-A-L. That's right, and when we're given the percentage of a compound, we can work out the R-A-R-A. Fabulous. R-A. I'm really proud of you. R-A-T-I-O. Yeah, the ratio of the number of atoms in the compound. To do this, that would then tell us the simplest whole number ratio of the elements in the compound, and that's how we'd work it out. So the actual type of ratio would be the S-I-M B-L-E-S, the simplest. Use that energy. Simplest. Just practice. Finish off with the R. Oh yeah, the simplest whole number. Okay. Now an example of this. If we had 9 grams of aluminium and it reacted with 35.5 grams of chlorine, what would be the empirical formula? Okay, so first of all we need to work out the ratio of the number of atoms by dividing the mass of each element by their relative atomic mass, so by their AR value. To start with, we divide the mass of each, E, L, E, M, E, N, T, by the value of the, you can use the abbreviation, come on, use the abbreviation. So divide the mass. So divide the mass of each element by the value of A. Oh, great. So in the case of aluminium, the mass is 9 grams and the atomic value is 27. That's aluminium, Al. Chlorine, the amount is 35.5 divided by the AR value, So for aluminium, the fraction you get would be, when you divide 9 by 27, would be 1/3. And for chlorine, when you divide 35.5 by 35.5, you obviously get 1. So from that, we can work out the ratio. Now, so according to that, if the ratio, we need 1/3 of a mole to 1/3 of a mole of aluminium to 1 mole of chlorine. The ratio would be, in whole numbers, would be chlorine, 3, fab. And then we do 2 dots, and aluminium would be 1. Fab. So we can get that for each aluminium atom you need 3 chlorine atoms to react. Now create the empirical formula for that. You'd start to use the chemical symbol Cl and Al, and you would obviously add in the number of atoms that you need. So the empirical formula using their symbols would be starting with Al. Cl3. Fabulous. Okay. We'll do one more. Yeah, we've got one more example and then we'll just do a long question at the end, okay? Now, if a compound contains 16 grams of sulphur, symbol for sulphur is S, and 24 grams of oxygen, symbol is O, what is the empirical formula? So again, we're doing the same thing. So first of all, we need to know the AR values. So just out of interest, do you know the AR value of sulphur? Yes or no? No, it's 32. I wouldn't have known it either. So we know that the oxygen value is actually 1,6. So we're going to divide the grams. That's right. So we've got 16 grams of sulphur divided by the atomic mass, which is, what did I say it was? I said it was 32. So 16 divided by 32 will give you 0.5. Great. And of oxygen, we've got 24 grams divided by 16, which will give you 1.5. So for every half a molecule of a mole of sulphur, you need 1.5 moles of oxygen for it to react. Now, we've got to work that into a whole number ratio. So the whole number ratio would be, we'd obviously take sulphur up to 1. So how many oxygen atoms would it need to react? 3. Great. So the empirical formula, starting with sulphur, would be SO3. Okay, wonderful. Okay, so that's how we can work it out forwards and backwards by giving a certain amount of information and then using the masses and the atomic mass values to work them out. Now, what I'd like to just have a quick, just to finish off on the long question, I find it more difficult presenting to you on like mathematical things. You know, we all have strengths and weaknesses and we all have things that we need to work on. I just really appreciate any feedback on how I did today.
For me?
Yeah, just for 5 minutes. But you can tell me any way that I could maybe do it better or anything. I'd really appreciate it because I find it harder and I'd probably stay away from more things like that with you. And I know you love maths, so I'd like to do more of it with you. So is there anything you can tell me about today that might, from the lesson, that might be helpful? You have to put your legs. Can you sit up for me? Well done. I-E, N, J, O, Y, E, G, I, T. I enjoyed it. Okay, cool. And is there anything, the way I presented it, is there anything you'd like me to change? Y, E, S, yeah. What would you like me to change? I, A, I am, great. I am, A, B.
Father.
Yeah, you're just telling me and helping me to improve. A, B, L, E, I am able. T, I am able. Oh. Chris, come back. Let's finish this off. Let's come back over. Finish this one off. Then we can bounce. Let's finish our conversation. So you were telling me I am able. You can stand up if you want. I am able T-O-2 W O-R. Okay, I'm able to work. I'm able to work. Keep the conversation. I really want to hear what you've got to say. So use your energy into here and to explain to me. Let's finish your sentence. I'm able to work. T H I N G. Work things. O-U-T. I make work things out. I-N-M-Y-N-I H-E-H-E. Keep it going. G-A-D. You're doing so good, you can get this out, come on. You're doing really great. Keep it going, keep your concentration, it's fab. Keep it going, come on, let's finish this up. So Y, faster, Y, O, U, so U, where are we going? D, O, M, T, H, A, V, E, T, O. So you don't have to. Brilliant. C, H, E, C. Okay. So you do, oh, okay, brilliant. So I won't check anymore. Is there anything else that you'd like me to do differently? Anything else? Yes or no? Yes?
No.
Oh no. Okay, just one check in. Was the speed okay for you? That we went with the examples? It's really keep it going. It was. We'll wait a minute. It was. Finish this up. Finish your sentence. You were telling me the speed. It was. Okay. Fab. Okay. Thanks for telling me that thing, and I will definitely not do that anymore. And I'll keep trying to practice if you enjoyed it, and we'll try some more stuff like that, yeah? And then you can keep giving me feedback, and then I'll keep getting better. We'll work together. Did you have a message for anyone today? Message or question? A message. Who for? Mum, Penny, Alex? For Mum. Oh, for Alex, okay. Might want to sit up there, it's easier. I, A, N, L, O, K, I, M, G. I am looking. Let's go back. Let's finish your message, Alex. I am looking. Here you go. I am looking. F, O, R, W, A, R, D. I'm looking forward. I'm looking forward. T, O, Y, O, U, C, O, M, I, N, G,